This presentation is on isotopes and average atomic mass. So by the end of this presentation, you'll be able to do two things. One, describe isotopes using hyphen notation, and also two, calculate average atomic mass. So first we're going to talk about something called mass number. So this describes everything in the atom that has a heavy mass. So remember that the electrons weigh practically nothing, like 1/2000th as much as protons and neutrons. So the mass number is the number of protons plus the number of neutrons in the nucleus of an atom. These are the only two subatomic particles that really contribute to the mass of the atom. However, not all the atoms of the same element have the same mass number. The most important thing to keep in mind that the number of protons in an element has to be the same. If the number of protons changes, you have a different element. So protons don't change. However, the number of neutrons in different atoms of the same element can vary. So let's look at an example here. We're going to look at chlorine. And if you look at the square from the periodic table, above the symbol is the number 17. This is the atomic number. It tells us that chlorine always has 17 protons. Now, let's think about neutrons. Chlorine can have either 18 neutrons in the nucleus or 20. So some atoms of chlorine have 18, some atoms of chlorine have 20 neutrons. All atoms of chlorine have 17 protons. So how do we communicate that about the atom? How do we communicate which atoms have 18 neutrons and which atoms have 20? We're going to use something called hyphen notation. A hyphen is just a little dash, and you'll see that in a minute. So first, an isotope is an atom of the same element, but that has different numbers of neutrons, and we identify it by its mass number. So let's look at our chlorine example again. Remember that chlorine can have 18 or 20 neutrons, and it always has 17 protons. So atoms of chlorine that have 18 neutrons, and of course 17 protons, we're going to add 18 plus 17 to get the mass number, and we're going to put it after the word chlorine, after a little dash. So chlorine that has 18 neutrons is called chlorine 35. 18 plus 17 is 35. The other isotope, so that guy's called hyphen notation. The other isotope of chlorine has 20 neutrons. So that is 20 plus 17 to give us the mass number of 37. So the other isotope of chlorine is chlorine 37. So here we have the hyphen notation for the two isotopes of chlorine that you find naturally, chlorine 35, which has 18 neutrons, and chlorine 37, which has 20 neutrons. So then, let's think about this number underneath the name chlorine on the periodic table. It's called the average atomic mass. It's located underneath the element symbol. So there's the average atomic mass. This tells us how much an atom of chlorine weighs. But it's not a whole number. You might think it's equal to the mass number, but it's actually equal to the weighted average of the masses of the protons and neutrons in all of the isotopes put together of that element. So let's look at an example. We just talked about that chlorine exists as two different isotopes, chlorine 35, which has 17 protons, of course, because chlorine always does, and 18 neutrons. And then we also have the isotope chlorine 37, which again has 17 protons, as chlorine always does, and it has 20 neutrons. So we're going to calculate the weighted average of the masses of those two isotopes. So experiments have shown that wherever you find chlorine in nature, it is in the same proportion, it's in a mixture of chlorine 35 and chlorine 37. You always find 76% chlorine 35, and you find about 24% chlorine 37. So chlorine 35 is a little bit more common in the environment. So we're going to take these percents and the mass numbers, and we're going to calculate a weighted average. So here it is to review again. And here's the equation for a weighted average. You're going to take the mass of the first isotope times the percent of the first isotope, and then you're going to add that to the mass of the second isotope times the percent of the second isotope, and divide the answer to that by 100. So really simple. We're going to start with the top isotope, chlorine-35. The mass number is 35. We're going to multiply that times the percent of that isotope, so 76%, plus the mass number of the second isotope, which is 37, times the percent of that second isotope, which is 24, and we're going to divide that whole thing by 100. When I do that, I get 35.48. And the units here are AMU, which stands for atomic mass units. So if you have a sample of chlorine, you'll have two isotopes, but the average mass of the atoms in that of both isotopes is 35.48. Notice it's a little bit closer to 35 than 37 because there's more chlorine-35 in the environment. So at this point, you are able to describe isotopes using hyphen notation, like chlorine-35 or chlorine-37. That's the mass number at the end. And you can also calculate average atomic mass to determine the weighted average of all of the isotopes of any element.